Guys are in the textbook also, and also on the handout, but know how to use them. Now, Shane, you don't mind, do you?
Nope.
Okay. On one side of the handout it says section 11.1, 11.2, 11.3, sequences and series. So wait, Ramsey, we just showed some of those. Okay? So I'm going to take a look at just a few of those examples. Please tell the class what the first one is. Letter A there.
2 plus 4 plus 6
Okay.
plus ellipses,
Okay.
2 plus 100.
And now to stop at 100. And when I do that, from my handout, it looks like it says, find the sum. That true? 2 plus 4 plus 6 out to 100, and tell me what all those numbers add up to. I would like to apply some of these formulas if I could. Now, I think I gave you a hint there on the handout. Can I rewrite in summation form, start with the 1 down here, what 2 plus 4 plus 6 plus 8 all the way down through 100 may look like? First, let's get the formula out of the way. What formula should I stick inside here to give me those terms? 2k. If I replace k by 1 to get 2, k by 2 I get 4, k by 3 I get 6. Now, since I know what the formula is, what would I have to place at the top to get 100? 50. And now I can do it. I love this. You know your formulas, you got this done. Now, I am going to pull that 2 out front, as we saw earlier. And if I do, that's going to leave a summation from 1 through 50 of merely k. And then, better yet, that's 2 times the summation for k. N times n plus 1 would be 50 times 51 all over 2, Mr. Gauss's formula. That's the formula. 2's canceled. So whatever the answer is 50 times 51. Someone help me out. Is that 2550? I did it quickly in my head. 50 times 51. I think it's 2550. Please check and see if it is. Is it? Yeah. Okay. And that's the grand sum. So if you don't trust the formula, add them up. Directly 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus out to 100 and add them up. The formula says 2550, if I have no mistake. Okay, we got that. Shane, tell me what the next part on that handout's asking.
Find the sum of 2 plus 5 plus 8 plus ellipses all the way up to 41.
Love it. Love it. Now you're going to rewrite this for me on the test. First use the summation. So if I rewrite this with the sigma summation, and then I'm going to start with 1. Now guys, this one may be a little bit tougher. Can anyone come up with a formula first to give me those terms, like over here it's 2k. Does anyone have an idea what the formula is there, Alex?
Would it be k to the power of, I'm making it up right now.
Okay,
K
okay.
to the power of n plus.
Wow. That may work. That may work, but that's not what I want right now for this one, for a reason. By the way, is there a pattern of some sort, though, in the numbers? I went from 2 to 5, and then 5 to what? 8. Do they differ by 3? So there might be a 3 in the formula you're looking for to give you those terms. Mr. Hahn, what's that?
3k minus 1.
He says 3k subtract 1. If I replace k by 1, do I get 2? I think I do. Replace k by 2, I think I get 5. Replace k by 3. 3 times 3 is 9, minus 1, 8. And now I know what to replace here to get the 41. And that would be, what's the top number? 14. 3 times 14 is what, 42? Is that true? And then 42 subtract 1 is 41. So all this she gave me to find the sum for can be expressed with a summation. And therefore, since I've now expressed it in summation form, I can use the formulas. So guys, let's split this up. I'm going to do it quickly. Move the 3 out front, which I'm allowed to do by formula, from 1 through 14 of k. Subtract summation of k is equal to 1 through 14, 1. True? Split up. Now this becomes 3 times, and here comes Mr. Gauss's formula again. It's going to be 14 times 15 all over 2. The last one's a gift. It's what? 14 times 1, which is 14. With the help of the formulas. Going back to the first part here, guys, do not let me make mistakes. This is what, 7? So what's 21 times 15? Someone help me out. 315. And I guess 315 subtract 14 gives me 301. Is that true? And there's your answer. So all of these should add up to, if you wish to test it, 301. Aren't those formulas wonderful? You can write this in summation and then you can get the answer fairly quickly. Shane, what else was being asked?
Find the sum of the first 120 terms of 14, 16, 18, 20.
Oh, 14 plus 16?
There's a comma.
Oh, comma there, just the terms, 14, comma 16, comma 18,
Yep.
and it goes out to,
Well, it said 20, and then it doesn't have an endpoint, but it says go to the 120th term.
they want to write the sum of, right?
Yeah.
The sum of, here we go. So they're saying start with 14, add 16, add 18, and stop where? Or they're saying 120 terms should be there.
120 terms.
Oh my goodness. That's the one I thought not to put on the handout. But I need a little help here on this one. Can anyone be clever and tell me? By the way, guys, she's asked me to write or find the sum of the first, read that to me the way it's phrased.
Find the sum of the first 120 terms of 14, comma 16, comma 18, comma 20.
Write the first 120 terms. My translation is, Billy, they differ by 2. I could count. Are there some terms missing though? She says write the first 120 terms, and they gave you a hint that some of the terms are these. Guys, should 12 be in there?
No.
Should 10 be in there? Should be 10, what is it, 8, 6? Are there some terms missing? Because I think it's phrased write the first 120 terms, and they gave you a part of that. Shane.
Couldn't you just say k equals 14 to start at 14?
Okay, you want to start at 14 and go all the way through in 120.
Well, pass
It looks like, okay, here we go. So tell me please, guys, this is a tougher one, I guess. If I start with 1, be very clever, and if I translate like Shane wants to translate it, I need a formula inside here, and there's something on top here, and then we can apply the formulas.
I would do k equals 14.
Hang on now, K,
No, down below.
oh, down here, look at this. That's what I'm saying. K is equal to 14. Wow, not 1. And what's inside here?
K plus 2.
K plus 2?
Yeah.
Hang on. Now, be careful. If I put K plus 2 right now and put a 14 in there, my first term becomes 16.
Oh, so then first term would be 12.
So the first term should be just what, K?
Well, what? No, change
Nope.
the base to 12.
Nope. I see exactly what you're thinking. I love the way you're thinking there. Guys, K plus 2 is not gonna work, because that would give me what, 14 plus 2, that would give me what, 16. This one's crazy. I need a formula. I know they're different by 2. She wants to start with 14. And she's approaching it a little differently than what I was going to approach it. Anyone have an idea what the formula might be? You start with 14, you're going to add to it 16, add to it 18, add to it, she says you want the first 120 terms of that. And Shane, I thought you had it first. I see what you're doing though.
So did
But I just need to come up, exactly, but I need to come up with a formula. So when I replace K by 14 in that formula, you get 14. When you replace K by 15, you get 16.
Would the formula be able to be division?
Tell me again.
Would the formula be able to be division?
It can be division.
I was thinking, what, K squared divided by K?
Whoa, whoa, whoa. Well, K squared divided by K is K. So I'm back to her. I'm back to Shane. Yeah, K squared divided by K is K, right? So we're right back to K. Okay, guys, this is what I was thinking of doing on this one. Read that to me one more time and I'll show you what I was thinking about doing.
Find the sum of the first 120 terms of 14, 16, 18, 20, and then ellipses.
Jeez. Before I erase this, I'll see exactly what she's doing, unless somebody can come up with a formula, which I'm standing here trying to come up with one myself. Replace K by 14, get 14. Replace K by 15, get 16. Right? It's not K plus 1, is it? No.
Because the next term is.
Exactly. K plus 2, I don't think it's K plus 2. There might be a formula out there somewhere, I don't know, maybe, jeez.
2K.
There has to be a formula out there. They differ by 2. Hang on. Mr. Park, do you think you know what that formula is on this one? Started out with a 14, we're trying to do a summation, and we're trying to come up with a formula, and we don't get bogged down in this. Yes,
Maybe 2k minus k.
tell me again.
2k minus k.
2K minus,
K.
That is K.
2K minus K.
Yes.
That's back to K.
Okay.
Oh, I love that. Billy, K squared over K. K. Shane, just K. Daniel says 2K minus K. K again. Yes.
Can I add another sigma?
Oh, you want another sigma?
Oh.
Okay, so what the other one is?
K is equal to, I don't know, base is K
You
equal
want to start with 1?
14.
14, okay.
Yes.
Hold on.
And to 240.
200, how much?
240. Oh, I'm sorry, I missed.
I need the formula.
Yes. The formula should be K. And, yeah, and another
You
sigma.
need another sigma inside this sigma?
No, not
But you need another separate sigma.
another sigma for to
But what are you going to do with
subtract-
the two? Are you going to add them?
to subtract?
Subtract them?
A
Yeah,
subscript.
Oh, subtract them.
because we have to take odd number.
Oh, so in other words, we got issues. We've got issues. I don't want to get bogged down because I've got so much to do tonight. Did you see the issue?
Yeah.
That's why I brought that in. Okay. See if you would accept this. Mr. Hahn, you might be thinking sort of along the lines I'm thinking here. Let me do this real quickly and see if it'll work. could I find first, let's start with 1 through, I guess, 240.
Not 240.
Huh?
If the K is
No,
That would be 120.
120.
120,
Of 2K,
plus 12.
okay, let's put, if I do that, guys, let me write out what that looks like. If I replace K by 1, I get 2. K by 2, I get 4. K by 3, I get 6. So far, so good. K by 4, I get 8. Next will be 10, 12, 14, 16, 18, and so forth and so on. Now, she's asking, Professor, they just want that much. That true? That's what they want. They just want that 14 plus 16 plus 18, so forth and so on. But suppose I find all of them, and I think there's a nice little formula for all of them. Is it 2K?
Yeah.
Find all of them first,
So would you subtract?
and then subtract. And if I subtract, what? Subtract the first, Shane? If I subtract that, would that then lead me what we want?
Could we also just put like K
Could
equals
we
7?
Yeah, there you go. Now, let's see what happens here. I see some hands going up right here. Could I say, Professor, go ahead and find this. If this one's so small, I could actually just add them up. But in sigma notation, Alexandra, I heard what you said. Would that be like K is equal to 1 to what, 7? Of 2K. Yes or no? That little piece. Is that true? Now, can you tell me what would all of it be? Because I need a formula for all of it, because then I'm going to subtract this part
Would it be
from
6
it.
on top?
Okay?
Because you want the 14.
Here we go. Here we go. Hang on. Interesting.
Wait, is it not a 6 on top?
Oh, down here?
No, yeah, there.
Yeah, 6 here.
Yeah, yeah.
You didn't say 7, did you? 6.
You were right.
Then, there you go. K is equal to 1. Guys, was that 120 for all of it? Did we say 120 earlier? Oh, no. 2K, subtract, now please tell me, let's see if this makes sense first before I leave it. Does this right here represent all of them? The first expression? Does that represent everything? She doesn't want everything. She wants you just to sum up this much. So I subtracted the first piece. Does this right here represent the first piece in the blue? Now, should that give me what I want then? And then what you'd have to do, I'm not going to actually finish it up. Guys, you can find the answer for this one by moving the 2 out front and use one of those formulas. Mr. Gauss's formula, I guess. And this one right here, same thing. Move the 2 out front, use Gauss's formula, and get a grand sum. Is that true? Should I finish it up before I actually see what that sum is? Or could you guys do it on your own? Is it just right back to formulas? Yes?
Can't we just do like 2K plus 12 and then, or K equals 12?
Oh, you mean right here, right here?
Yeah, just instead of like doing the sum, just like,
You mean right, I heard 2K plus 12.
yeah. And
Oh, you got 2K plus 12. Hang on.
like 1,
And then go from 1 up to what? What's my first term she won? 14? 1 up to, what, 6?
No, then it would be up to 120.
120?
So,
It might work. You said 2K plus 12. Gotcha. So you're saying, Professor, just write 1 sigma, get it out of the way, 2K plus 12. K is equal to 1 up to, what was that, 120?
and this,
Wow.
But then it would jump numbers.
no.
No. Whoa. Hang on. I gotta move on here. Here goes. 1 through, you got 2K plus 12. I see exactly where you said that.
Just keep the
And
numbers.
if I replace K by 1 in this formula, you get 14. Is that what I wanted to start out with? Okay. Replace K by 2, I get 16. Oh, he's giving me 1 without using 2 sigmas, just 1. And she says, Professor, you got to end with, they want the first 120 terms. Oh, Lord, are you saying 120 here? Guys, you think that one single sigma would probably give it to me? And in my mind, I was thinking about maybe doing this business here. Did you guys sort of follow this other method here, find all of them, and then subtract the first 6, I guess it was? And she gets the same answer? Okay. I'm not gonna go through the calculations, but you can use the formulas here. Beautiful. Shane, what's next?
Okay, summation starting at k equals 1.
Oh, got you.
This is gonna take us
Uh-oh, hang on, okay. Starts with 1.
up to infinity.
Uh-oh.
Oh, we just
We did one like this.
Yeah, you did this one already.
Okay, already done it.
Okay, so then we've got convergence of an infinite geometric series.
Okay, then they gave you a formula.
Yeah.
And they call it infinite. You're summing forever, and I did an example for you. They're saying this right here could have been done without us. I love this though, guys. You see, it is approaching 0.3 with the 3 repeats, which is equivalent to 1/3. She's telling me, Professor, if you want to use a formula for an infinite, what was that formula? A1 over 1 subtract R?
Yes.
And guys, in this case, A1, my first term was what, 3/10? And the formula says 1 subtract, if you want to use it. R is for the ratio. What was the ratio from here to here? I had to multiply by how much? 1/10. In fact, you see it right there in the formula, in the equation. 1/10 is my ratio. So guys, I think if you use that formula that's mentioned on the handout, you get 3/10 over what? 9/10? 10s cancel. 3 over 9. There's your answer. If you want to use the formula for an infinite series like this, I prefer just write out, add them up, and see what it's approaching, what it converges to. Shane, is that pretty much done now for that particular part?
Yeah, no, we're in section 11.4.
Tell me, section now, what now?
11.4,
Hang on,
which is method.
gotta get this done. I have a handout also, but she says, Professor, it takes me down to 11.4, it says what? Math induction.
Yeah.
Okay, I'm checking my time here. Let's do one example of math induction, what they call math induction here. Guys, I brought in a nice one here. Yes, I did. Here we go. Now watch carefully. I'll show you one. Let me do this, guys. Let's call this part 3. I think I'm moving into part 3 here. And she says from the handout, there's a section known as this. And guys, in parentheses, I'm gonna say it's merely this. You're doing a proof. It's called math induction. I don't think I had an example on the handout. I just used the words math induction. So math induction is a process of proving something. I have one example. Alexandra, here we go. If, yes, here we go. You're given this statement, 2 plus 4 plus 6, so forth and so on, out to 2n is equal to this. You guys have got to make all these lessons connect for you. This is the only one I'm going to do. They're saying, please prove that statement is true for all integers. Positive integers. Please tell me first, to get a start, just to see what this means. Can anyone tell me, based on what we've done in class so far tonight, can anyone tell me what the left-hand side looks like using sigma notation? Because they are adding, they're summing. And I'll start with 1. So let's make it relate to something we've already done. What would the left-hand side look like, the best you can, in sigma notation, summation notation?
2k.
From, okay, 2, K, or, you know what, let's use n here. Gotcha. K here? Okay, up to N, hang on.
No, shouldn't it be a K on the side then if we're starting at that?
Okay, let's use K equals 1, like that. Now, let's see if that makes sense. Is that the left-hand side expressed just with summation? Says replace K by 1, I get 2. Replace K by 2, I get 4. And finally, we have to replace N, K by N, do I get my last term? So is that left-hand side merely that? So they're saying sum those up. You say, Professor, I guess I know how to sum that up. You do this. 2 out front by formula. You're going from 1 through N of K. Is that true? Or 2 times. And guys, what's the best I can say for my formula, which I don't think I've erased yet? Oh, it's back here. So what can I replace that with by formula? Is it N times N plus 1 over 2? That goes here by formula. Two is canceled. What am I left with? N times N plus 1? And what they say it should be equal to? N times N plus 1. If I apply the formulas. Now, you'll say, Professor, that's all you have to do for a proof there? No, I applied the formulas, because I'm talking about formulas tonight. No, the proof, and here it goes, we'll just set you up. They're saying, please show, and here it goes, guys, we'll erase this. That's what it means. Can anyone first tell me before I jump into the proof? Can anyone tell me what the value of the 8th term on the left-hand side, what value would the 8th term have, based on what you see? What's the value of the 8th term on the left-hand side?
16.
Tell me again?
16.
Tell me again?
16.
16. It's 16. Just replace N by what, 8? And you get 16. What's the value of the 50th term if I need it? 2 times 50, 100. What's the value of the 125th term? Merely replace N by 125, and guys, what is that? Help me out, 250? So that's what the left-hand side tells me. You can find the value of any term you wish. What on earth is the other side telling me? So I was going to just first describe for me, what does this mean? This tells me any particular term I want, I just replace N by that number, and that tells me its value. That's the easiest thing there on the left-hand side. What's the right-hand side telling me? For an example, if I replace N by 2 on the right, on the left, by the way, if I replace N by 2, I get 4, which was, sure enough, the second term. Replace N by 3 here, on the left, I get 6. Yes, that was the third term. If I jump over to the other side, though, and replace N by 2, this is 2 times 3 is what, 6?
That's the sum, no?
Replace by 4, 4 times 5 is what, 20? Is that true? Replace N by 2, N by 3. N by 3, I get 3 times 4 is 12. What's that? That's the sum of the terms. So this side here tells me a particular term, specific term, you can find quickly. This tells me the sum of those. So let me just test it right quickly. The value of the, let's say, the 15th term on the left-hand side would be merely what value? 30. Now, what's the sum of the first 15 terms? That's where you turn to the right-hand side. The sum of the first 15 terms would be this. Whatever that number is, that's the sum of the first 15. The right-hand side is telling me the sum of the first 15. The left-hand side is just telling me merely the value of the 15th term. They differ. And they differ so much, you say, Professor, are you sure those two sides are equivalent? We're supposed to show they're equivalent. I think I did by sigma first, and they got the same answer. But now a nice little proof to show those two sides really are equivalent. I'm going to do one little part of it, then we'll take a break. Just one little part. There's 3 steps to this to show. By the way, guys, 15 times 16, help me out. What is 15 times 16? 240. 240?
Yeah.
So the sum of the first 15 terms is 240. the value of the 15th term is 30. That's the left-hand side. Now, they don't look like they shouldn't work, but here goes. You're proving now, and they call it induction proof. First, you got to show that the statement is true at the beginning. In other words, when n is equal to 1. Just show at the very beginning the statement's true. Now, at the initial, n is equal to 1, that means on the left-hand side, you're trying to show 2, which is the first term, is equal to, on the other side, replace those n's by 1. Do I also get 2 there? So the left-hand side, the initial, start out with a 2, and you got to show that's equivalent to when you go down here and replace n by 1 down there. And did I get 2 to match up on both sides? That's all you have to show me. It's true at the beginning. What you're hoping is on the test, if I gave one of these on the test, you're hoping, Professor, I tried this and it didn't work at the very beginning. And you get to stop and say, that statement up there is false. That statement's not true. But it looks like right now this one may be true. Step 2, now we'll just set you up and we'll take a break. Now show the statement is true. Look at this, guys. At, now, before I put that at, conclusion to that at. Let's say I have the patients, and you have the patients, and I start with my first student, and I ask my first student, please tell me, is this statement true at n is equal to 1? My first student would say, Professor, 2 is equal to 1 times 2, 2. You get 2 on both sides. Now I go to my second student. Please show me it's true at 2. No problem, Professor. 2 plus 4 is 6. Down here, I'll put a 2 in here. That's 2 times 3, 6. My next student, Alex, I say, now show Alex that statement's true at 3. I got to show it's always true. By 3, 2 plus 4 plus 6, guys, that's what, 12? Put in a 3 down here. 3 times 4, 12. Liam, 4. Liam checks and says, Professor, the two sides are equivalent. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I just talked to a professor who has only 3 students remaining. I've got 22 still here. Proud of you guys. Now I go all the way through, and I finally get to my last student. And let's say I have my last student say, let's say 20. I have 20 students maybe tonight. Please show me it's true for the 20. It may be trying for that student by the time they get it, because they need to add up the first 20 terms on the left. They've already got the hardest one. And then they're going to replace n by 20. Trevor, would you get the hardest one back there? Then replace 20 on the right-hand side. Say, Professor, it should be equivalent to 20 times 21. Is that true? Or 420? I think it's 420. Is that true? Now, am I satisfied as a student and as an instructor that that statement's always true then? My class says it is. Am I to accept it's always true? Is it true at 21? Then I have to go back and say, we're going to start with 21 again. Then 22, 23, 24. Daniel's going to replace n by 25. He's going to have the first 25 terms on the left-hand side, which is going to take forever. And then replace 25 on the right-hand side. They match up. He smiles. I smile. Oh my goodness, that statement's true. I go all the way through. And Trevor in the back there, he's going to end up with a number like 30 or 35. Now, am I satisfied and say, I'm done? That statement's true. No. We're supposed to show it's always true. So before we take a break here, guys, you know we can't just go through and through and through. So they're saying, please. Now, they like to use the word here, assume. And you know what happens when we assume things. But assume the statement is true up to a certain point. I can have Trevor to add up the first 35, and all of a sudden he says, Professor, that was a long one. I had to 2 plus 4 plus 6 plus the first 35 terms on the left, Professor. That's wipe me out. And then replace n by 35 here, and then it matches up. Then we go back to 36. We can't do that forever. So they're assuming it's true up to a certain point, and they call that certain point n is equal to k. It's true up to a certain point. So I might say my first 22 tries here, my students, and Trevor gets number 22 back there. Every student showed me it's true for the first 22. My k would be 22. I'm assuming it's true up to that point. I think I'll go further. Now, I know we're going to take a break. Can anyone tell me what step 3 will be when we get back? And the most important step of the 3-step proof. What must I show now if I'm assuming it's true up through the first 22? What would be a good way to express, I'm not satisfied, I must do what to in the next step?
Assume that, I'll show that n equals k plus 1 is true.
You gotta go one more. So if I'm assuming it's true at k, my next step is now, step 3 when we get back, now show the statement is true at what? K plus 1. That would represent 23. Now, am I satisfied there? No. K plus 1 again, 23 plus 1, 24. 25, and it just continues going and going and going. If I can show step 3 when we finally get back are equivalent, the two sides are equivalent when I do my work, that statement's true for all positive integers. That's called induction. So I'm going to just do this one proof, then we'll move on. Guys, any questions at this point though? Take your 10-minute break.